wanted to talk about the WEKA data platform environment. And nice to meet you. My name is Shimon Ben David. I'm the Chief Technology Officer of WEKA. So talking about the challenge that we wanted to solve, WEKA, by the way, exists for 9 years. We actually just announced a Series D of $135 million in the last 3 months. This is the problem that we wanted to solve. We saw that there's a lot of environments that optimize, storage environments that optimize for simplicity, speed, and scale. So a lot of customers, when using storage environment, had to choose between NAS appliances that are very simple to manage, but they don't scale very well, and they're definitely not fast, or NVMe over Fabric environment, for example, or other block environments that are very fast, but cannot really scale, and they're very difficult to manage. And there's other object store environments or cloud environments that can scale, but they don't perform as well. So we wanted to create an environment where we can provide all of these three properties. So easy to install on any protocol on-prem in the cloud, be resilient to multiple issues, be resilient to hardware failures, definitely be a fast environment, and scale to terabytes, petabytes, and exabytes. So that's what we did. Just a few words about the company. We're in the Gartner Magic Quadrant. Actually, today, this is from last year, today we're actually at this place. We have a very nice logos. 12 of the Fortune 50s are WEKA customers. Most of our projects are actually in the AI ML space. So when we'll talk about the WEKA environment and the performance characteristics and the other capabilities, data movement and protocols, you'll see how that transpires. And WEKA is an environment that can run on-prem and on the cloud. And as a result, and we built it from day one to be cloud native. So as a result, the environment, we already have a massive amount of customers on the cloud as well. And we'll talk about it. We are also in Gartner peer reviews, and we got a very nice number of customers saying a lot of nice things about us. So what is the challenge that we're seeing today that WEKA is solving? What we're seeing is that there's a lot of environments that, again, as I mentioned, there's multiple storage environments at every single customer. And customers are now transforming to working in a pipeline environment, meaning that they generate data somehow, they push it to a centralized environment, and then they need to compute on the data. While doing that, usually we see that they copy the data to a faster environment than the one that they put the data on, because maybe I have an object store here that can accommodate for petabytes of data, but it's not really performant. So maybe I'm copying the data to another parallel file system or to another local NVMe of my GPU servers, for example, which are very IO intensive, very IO hungry. Maybe I want to move the data to another location to perform backup and DR, or maybe I want to move it to a tape or to a cloud for backup. So there's a lot of data movement in current organizations, and this could be financial organizations, life science organizations, healthcare organizations, just plain out AI research and HPC environments. So we're seeing that in different environments. And what we're seeing is that the reason for the movement of the data is due to 3 things. First of all, it's the ability to scale. So, hey, I'm moving the data, I'm aggregating the data to a single location because of the scale. But then the protocol compatibility of that environment is not suitable for all IO workloads. If my object store, for example, speaks S3 or NFS, now I need to run my high performance workload on it. I cannot, these are not high performance environments. So data is being moved because of scale, because of protocol compatibility, and also because of performance characteristics. So with WEKA, we're providing an environment, and that's what we'll show, that provides all protocol access to all data. So imagine deploying a WEKA cluster, and then you can access all of the data using S3, SMB, NFS, GPU direct storage, our own POSIX environment. We're actually also adding HDFS protocol. So accessing all of the data using all of the protocol, and that really facilitates the pipeline of pushing data using one protocol, for example, S3, and then working on it using the high-performance POSIX protocol, for example. So there's no need to move the data around and manage different and pay for different storage environments. WEKA will guarantee that the speed of the data would be even faster than the local NVMEs of the NVMe servers. And I'll show some numbers. So there's no need to move the data also because of the speed. And we can scale larger than the normal object stores even. So we have projects in the petabyte going to exabytes now. So it's that compelling. How is the WEKA environment deployed? What we do is we deploy WEKA on commodity servers or cloud instances. So as I mentioned, WEKA is software only. The only requirement that we have from these on-prem servers or from these cloud instances is for them to have NVMEs and some sort of connectivity between them. And what we do is we install WEKA across them, and we create our cluster across these servers. So we just need the servers and the NVMEs or the instances and their local instance store. I'll mention what we don't need. We don't need any JBODs or JBOFs or RAID arrays or storage class memory or NVDIMMs. Because we are designed to run on the cloud from day one, we didn't want to use any proprietary hardware that may or may not exist on different clouds. So therefore, we're doing all of the logic, all of the protection, all of the erasure coding, all of the metadata distribution, all of the acceleration, all of the resiliency, we're doing within software with no hardware assistance. And actually, that gives us a much tighter control of how the I/O works. And I'll mention that in a second. So first of all, just running on these commodity servers, we're able, or commodity cloud instances, we're able to run the environment. Once we deployed WEKA on these commodity instances, what we're doing is you're now able to carve it into multiple file systems. So your compute servers, whether they're GPU servers, whether they're CPU servers, containerized environment, can now access these file systems using all protocols. And obviously there's permissions mechanisms that enforces only legal access. Additionally, after we created that flash tier, what we're able to do, we wanted to also allow for a capacity tier. So we see customers in the double-digit, triple-digit petabytes of flash tier, but some customers would like to also not utilize flash for all of their data. So what we're able to do is we're able to utilize object stores, again, on-prem or on-cloud object stores to expand the capacity. So, and then manage all of that under the WEKA namespace. And I'll give an example of a production customer that has a 90 petabyte object store, OBS, that WEKA is connected to, and they have a 3 petabyte WEKA flash tier. And what we're doing is we're exposing that 90 petabytes to the compute servers. So the compute servers are mounting the WEKA file systems, and the file systems are residing anywhere on the flash tier or anywhere on the object storage tier, and WEKA manages that data. And we obviously can talk a lot about how we do that, how we distribute the data. I will mention it a bit, but we're doing a lot of acceleration, a lot of optimal decisions, so that there's a massive performance between the object store to the flash and between the flash to the compute servers. I'll explain a bit more. So for example, what we're doing, the way the data is placed on the flash environment is imagine that compute clients, and again, you can have 1, 10, or thousands. We have customers running thousands of servers mounted to WEKA file systems at any point of time. And in terms of how is the I/O working, imagine that what we do is we break every I/O into 4K pieces, and then we stripe these 4K pieces across all of the WEKA storage nodes. So for example, even if one server is writing a 1 megabyte block, what we'll do is we'll break it into 256 4K pieces, okay? And we'll stripe these 4K pieces across all of the storage nodes, all of the WEKA storage servers, in such a way that every one of them contains a few pieces of the 4 pieces, and we will protect that with our own erasure coding with an N+2 or an N+4. So it means 2 or 4 servers can fail concurrently, and the data would still be available and resilient and accessible. So by doing that, what we actually did is we created an environment that can provide massive throughput because we're now accessing all of the NVMEs in parallel. So for example, if I have 1,000 file systems here, and maybe I mounted one file system, that file system performance characteristics would have massive throughput. In addition, it will also have massive I/O operations. So for example, if I'm doing small IOs as well, because everything in the system is in 4K pieces. So what we see is that usually legacy storage environments are optimized towards throughput. So they're optimized towards for large IOs because they were created for spindles, and therefore they have a large block size, and therefore reading and writing large blocks, 1 megs or above, is very beneficial because that's the way it's easier for hard drives to perform. With WEKA, we do that by parallelizing the IOs across all of the NVMEs of the environment, as I mentioned, so you get massive throughput. But in addition, as I mentioned, because everything is in 4K, if you now need only 4K out of that 1 meg, we will read only 4K. Other environments will read the 1 meg and then provide a 4K. That's a huge read amplification. So it means that usually customer needs to choose the block size of their file systems, and they create IOPS file system, and they create throughput file system. With WEKA, and that's a very unique feature than other storage environments, for example, Lustre, GPFS, you don't need to choose. The file system is optimized toward throughput and IOPS. In addition, it's very optimized toward low latency, and we'll talk about why, and towards high metadata performance. So much in the same way that we distribute all of the data across all of the storage nodes, we also distribute all of the metadata. So, or actually I would say, we are running thousands of virtual metadata servers. So now even the metadata characteristics are split between all of the CPUs of all of the environment. So it means that there is no 1 or 2 metadata servers that just gets everything, and they need to provide the entire metadata for the entire cluster, which now makes them a hotspot, and that doesn't scale. It actually means that all of the nodes are participating in the metadata calculation, and there's massive metadata compute that can be accommodated. In a longer session, I would really be happy to explain on how we're doing this. But we created a scale-out environment, and what we did is we also solved the scale-out problem. Usually what we see is that when you add nodes, you get more performance with other legacy environments, right? With legacy environments, you're adding nodes, you're getting more performance, and then at some point it stops or even diminish. With WEKA, as you add nodes, the performance just continue to increase. So that's very important. That's a key characteristics of the systems. And I think that's a lot of the differentiation that's interesting. So in terms of performance, you're getting all 4 performance metrics: throughput, IOPS, latency, and metadata across all of your data sets. And what we see is that obviously modern data sets, AI, genomics, cryo-EM, life science, scientific computing, HPC, and others, obviously, are composed out of IO patterns that are both large and small. So being able to accommodate for all of that within the same file system and not needing to try and separate and optimize is immense. And as I mentioned, all of the data is accessible using all of the protocols. I'll run forward. Another key aspect of the system is the ability to move data, or as I said, to utilize different tiers of flash and HDDs together in order to accommodate for one namespace. So I'll give you an example. Maybe I have a data center, or this could be a cloud AZ also, right? What we're able to do is we're able to create that unified namespace. And I gave the example of a 90 petabyte environment with a 3 petabyte flash tier. And we were saying more or less, and now you can carve that into multiple file systems and use that joint capacity. And we can talk about how we're optimizing for that, where all of the metadata is always on the flash tier, so you get massive performance either way. In addition, we're able to say at that scale, in the multi-petabyte or exabyte scale, you're able to take snapshots. And again, if we're talking about differentiation between WEKA and other solutions have snapshots as well, but not at that scale. No other system can do a 90 petabyte snapshot, an instantaneous snapshot with no IO degradation. We can do it. We can take thousands of snapshots. In addition, we're able to push these snapshots to the object store in a way that now they're persistent on the object store, irrelated to the flash tier that pushed them. So imagine that you have a 90 petabyte file system, or you have a few thousands file systems on that 90 petabyte namespace, and you're just creating a backup of them. You're saying, hey, WEKA, just create a backup and push that backup to the object store every 1 day, every 1 hour. What it actually allows you, it means that even if this WEKA system is demolished, or if it's a cloud environment, maybe it's unprovisioned on purpose, you can now, at any point in time, bring up another WEKA system and mount these snapshots. So it's actually giving you a way to create your own local backup. And we see that actually customers are mentioning that as a huge advantage, because at these capacities, they don't want to use any backup software. No backup software can go over a few billion inodes or a 90 petabyte of capacity in an efficient manner and try to back it up. So the fact that we can send the data and we can present it to any other WEKA system is huge. In addition, we can send the data to a remote location, another data center, for example, or another cloud AZ, so that the system can now mount. So we see use cases where customers are creating many file systems and saying, hey, WEKA, push them to the remote AZ or data center periodically, maybe 1 hour, 1 day, or more or less. And their DR plan is so that if something happens to this entire environment, WEKA will just be able to run on the other environment, on the other data center, or the other AZ for a backup and DR plan. In addition, it's also very efficient for a cloud bursting environment. So imagine that, I'll do this. Imagine that maybe this is a data center and this is a cloud AZ. We see customers sending data from on-prem to cloud environments, so they can now run instances on the cloud and consume the same data. So cloud bursting, essentially. And then when they completed it, they just send the data back here, and this system can now continue working with it. So the data movement capabilities is crucial. And essentially, if we're looking at, I picked a multi-cloud AI training challenge. So maybe I have an on-prem environment. So obviously I'm running GPU servers, and these GPU servers are running multiple containers, and they're crunching on the data that's in the storage environment, in the WEKA environment. And now you first of all, you need an environment that can support hundreds or thousands of these GPU servers. I'll just give an example. One of our customers have 3,400 GPU servers in their environment, growing larger. They have other environments with other thousands of servers. And then the challenge is, let's say that now I want to burst to a cloud environment, maybe for the Oracle Cloud. So I need a way to move my containers, right, to run on that cloud, so I can move my compute. And there's various MLOps environments that can do that. And WEKA integrated with several of them. And additionally, after moving the containers and saying, okay, I'll just provision cloud GPU servers for additional compute, I need to move the data. And WEKA can move the data so the GPU servers can now work on the data on that cloud environment. So WEKA actually enable the data, avoiding that data gravity trap between an on-prem environment and a cloud environment as well. This is the WEKA architecture. It will take a bit of time going over it, but suffice to say that what we did, as I mentioned, we're running everything in our software. We're not running anything in hardware. The thing that we did here is we actually implemented a lot of kernel bypass. So when our nodes are communicating with the network, or when we're communicating with the NVMEs on the same servers that we are installed on, we're actually bypassing the kernel. We're talking directly with the registers on the hardware, and we manage their queues. We wrote our own network protocol. So we are not using TCP/IP, for example, and we're not using any other protocol. We're using our own protocol. We're running our own virtual metadata servers. And again, I will be glad to elaborate on a longer session about that architecture exactly. But the important thing is that everything that you see here, since your application sent an IO and we got it to our kernel module that just throws it here, and this is where the logic really begins. Everything since an IO is here until it lands on an NVMe in multiple 4K pieces is actually WEKA technology. So we have that tight integration of an IO life as it goes between the compute client, through the network on our protocol, through the virtual metadata servers that we wrote, through the SSDs, through our own, you can think about it, our own NVMe over Fabric environment, and the block, even the blocks placement on the SSDs. So there's no other component that is not WEKA. And that gives us a lot of capabilities that other solutions don't have. I'll give you some performance numbers with GPU direct storage. A single GPU server was able to get 162 gigabytes per second, which is amazing. One server, one mount point to WEKA. But in addition, it was able to get 2 million IOPS. So again, this is the use case of when you're running an AI workload, it's very throughput intensive, but it's also very IOPS, small IOPS intensive. And WEKA provide that on the same data set as needed. Eventually, what it actually allowed the customer to do, and I think we'll see it in the next slide here, or maybe I will show it here. So the customer was using their own all-flash environment to do a training. Their training cycle, their training epoch took 2 weeks. After WEKA, it took 4 hours. So these are the performance differences that we're describing. When you think about it, it's 87x. 2 weeks to 4 hours. So essentially, it's like saying you can do in 1 year, in what you did in 1 year, you can now do in 1 week. And that's very powerful because it means that you can now get to your business objectives much faster. Your business logic is running considerably faster. Additionally, another company that's using us completely reduced costs significantly, because if you look at the architecture, it's very simple, it's very commoditized. So the bill of material is very simple, servers with NVMEs and an object stores with HDDs. So there's no, as I mentioned, there's no storage class memory or other solutions that you need that are very costly. So this customer was getting in 26 times reduction in cost per genome. And they created these massive environments. Frankly, they could never even scale to that with their previous solution. and they got a 50x improvement on their performance. So their time, this is a genome sequencing company, their time to sequence a genome, even accelerated by GPU, was 50 times accelerated. Another company, another autonomous car company, accelerated their training epoch by 80 times. So that's huge. And also that with a flash and 8 object store tiers, and also a multi-data center solution where WEKA is sending the data to multiple data centers. What we're seeing here is also a comparison between the WEKA environment and other solutions. So we compared, and these are legacy parallel file systems. So imagine Lustre, DDN, GPFS. WEKA was, we just took a 1 petabyte capacity and compared. WEKA is significantly faster, 4 times faster, 3 to 4 times faster. If you're comparing WEKA to other all-flash NAS arrays, it's 300 times faster, right? If we're looking at the IOPS, it's even better because, again, as I mentioned, all of these environments, all of the legacy storage environments are very read-oriented and they're very throughput-oriented. And WEKA can do both on the same file system. So the performance difference here is significant. And eventually, if you look at the customer outcome, so if I look at this customer running their training, the throughput and IOPS and metadata performance as low as the low latency of the WEKA, this is what allowed them to run 87 times faster, because we can accommodate for every IO pattern while other solutions really cannot. So with that, I'll actually move to the next topic. Sorry, to the next topic that is that's actually the WEKA. So we have, and as you've seen, by being in the Gartner Magic Quadrant, they actually validated our number of customers worldwide. You have to have customers in all continents. Obviously, I started from Antarctica. So we have customers in all continents, all worldwide. As a result, we also have our worldwide support, our 24/7 support. It's Asia-based, it's Europe-based, and it's US-based as well. So we're deployed on all of these environments, supporting massive projects, actually, on all of these environments. And finally, I'm not a salesperson, but I will talk about the price characteristics, where the pricing is actually according to usable capacity. Again, whether you're running on the cloud or whether you're running on-prem, the pricing is according to usable capacity. There's a different cost for the price of the flash tier and a different cost for the price of the object storage tier. What we're seeing actually, for example, when running on a cloud, Oracle Cloud or other clouds, due to our capability of working with the data, maybe I'll go back here, of working with the data and pushing it to the cloud environment. So again, maybe working on the day on an environment, and then pushing the data to the object store. Even on that cloud environment, you can now unprovision your cloud instances. That really saves cost. What we can also do is we can also auto scale, and that's a key component that we have on-prem, but also on the cloud. We see it more on the cloud, where customers are running their workloads. As they need more capacity and more performance from the storage, the WEKA system just auto scales out as needed. And when they're done, they can just auto scale back in. That's also a significant price enabler. I think with that, I'll complete my sessions. If there's any questions in the chat, I'll be glad to answer a few. Okay, thank you very much. Appreciate your time.